Okay, I'm on. All right, thanks for joining. You're going to hear a lot of similar discussion to, I think, probably what we just heard, but hopefully you'll also see some more in there. So we're going to talk about effective API security and how application context and behavioral analysis plays a role in that. My name is Dan Gordon. I'm Director of Technical Evangelism at Traceable. Been around the space doing different things between development and operations, product management for DevOps and DevSecOps, and focusing on API security here at Traceable. So what we'll go through is kind of set some context. We'll talk about why there's a difference in web versus API. We'll take a look at some ideas about how you should be thinking about this, how you want to approach API security, what to look for, and then I'll do also demos if the demo gods are willing here, cutting between our tabs to kind of show you a bit of the product and show it doing some of these things. And we'll talk takeaways. So just contextually, I'm going to try and walk around and be over here. So just to set the stage, we started with a pretty simple stack relatively, and I think this is API security or API conference, so y'all know we pretty quickly got from this with a simple set of stacks that we needed to protect to needing to go in the wrong way. This is so weird. To having a more complex stack so that we could be resilient, so that we could scale, so that we could innovate faster. And what that stack added was things like Kubernetes and containers so that we could separate out our code from our infrastructure more. The cloud itself so that we could, again, scale and be more resilient. Applications themselves changed, no longer being pretty much off-the-shelf software versus custom. Right now it's SaaS, now it's hybrid, on-prem, off-prem. And we've got identity providers that are in the cloud. The clients have changed themselves. We're no longer, computers with browsers. We're mobile and IoT and services. Calling services is a huge part of this. So what this really means, though, is not the application stack change, but the attack surface changed, right? Because something that every single one of these layers now has in common is that they use APIs. Now, in different ways, granted, but that means that APIs are at the root of all of the technology and modern applications that we're working with. Put another way, from an application standpoint, if we look above at the application layers, we've got microservices or mini services calling other services that all each have potentially their own API written by different teams in different geographies using who knows what security methodologies. And this creates a complexity. This creates more of an attack surface. As a matter of fact, this is not just, if you're thinking the unicorns that are running that, right? This is 90% more at this point of enterprise applications, which are being based on API architectures. So again, context, we all know that here at the, with API, at the API conference, crossover, but there's a crisis brewing. And this is because there's challenges in how we protect our APIs. And what we're seeing here is, I don't put these companies up here to shame them. As a matter of fact, they're an example to make a point, which is these companies are some of the high tech of the tech companies. You can guarantee that they have the best security people working for them, that they have some of the best security budgets and tools of the day, right? But yet, these are attacks that happened in some recent years of these companies through their APIs. So what's happening here? 91% of organizations had an API security incident last year in 2021 in the survey. So what's happening? Well, API traffic looks like normal traffic to security tools, to WAFs, to RASPs, to our API gateways. Example is that, two here, Venmo had a public endpoint that a student scraped 200 million users' financial data off of. normal API traffic. Wasn't breaking in anything, just looked like normal API traffic. Coinbase, similar issue. So here's an example. We'll go a little bit deeper into, okay, why does that prevent or cause a problem for us? An example, data breach of a rideshare company. Now this API, this rideshare company rather, provides an API for drivers to refer their friends to sign up as other drivers. And when they do that, the driver then, the referred to driver is going to get on their client, their phone, their web device, and they're going to call this API effectively by typing into the app, hey, I want to join through this referral from my friend. And the system's going to come back, give them a user ID that's created an entity in the system. Okay, so far so good. The expectation of the code is that now the client is going to turn around and call and take that same ID that they just got and call get consent details. And that is going to ask the system to send information that's necessary for the application to provide the screen that the driver is going to consent, yes, I'm going to be a driver for this service. And what it does is it passes back the user object, the whole JSON user object of that ID. And the expectation is that the client is going to then filter out the information. This is a common activity, a common behavior. Filter out the information that's not needed and show the information that is to get the signature of or the consent of the new driver. And then everyone's happy and they move on. An attacker, however, can get to the authentication. I'm logged in as I got the ID 1, 2, 3, 4, 5, but then call that same API and find that they can send a different user ID. And now with that different user ID, the system's going to, in this case, not do the check of authorization. It's going to turn around and it's going to send the user object of a different user back to the rogue client or the attacker. And being a rogue client, it's not going to filter anything. It's going to, of course, make that all available. So what happened here? Right? Broken object level authorization. There was no validation of a current user that is authenticated, that they're authorized to see the data that they've asked for. So this is the #1 problem that we find out there. If you're familiar with the OWASP API top 10, that is a list of top 10 vulnerabilities. This is the top one. But the other thing that happened, and these go in conjunction oftentimes, is excessive data exposure. That JSON object that was returned back with all of the user data. Our frameworks are written to make developers productive and efficient. And one of the ways that has happened is the ability to pass back whole objects and to basically encourage, not intentionally, but this efficiency of how they move data. And because of that, we had excessive data exposure in this case, where more data than was actually necessary to return back to the client was made available. And in the case where it was a illegal or not correct authorization, that's a problem. So the attacker was able to steal PII records, steal authentication tokens, and get a full account takeover. So that's an example of where an API transaction, I'm going to jump back there, all of this looks like normal traffic to a WAF. It's an exchange back and forth with numbers that it doesn't really make the parsing of and define that one connection of one user and then later a connection to the API using a different user, that those are actually associated. And that's why it can't find these problems. So I mentioned the OWASP API top 10 vulnerabilities. This is a list of them. I'm not going to go through these, but we did see 1 and 6. Oh, no, not 6, sorry. 3, excessive data exposure. But I put this up because there is an OWASP top 10 vulnerabilities that you also might be familiar with. This has been out for a while. The OWASP organization, the Open Web Application Security Program or project. And they've defined what are the main vulnerabilities with basically web applications. This has been out for a while, and this is what WAFs are basically built to protect against. Cross-site scripting, SQL injection, SSRF, et cetera. And should say something that this organization said, you know what, we need a different list for the APIs. And there are some similarities, injections on both of them, but even how those injections work and how you find them and how you protect against them are differentiated. So the fact that there's a separate list tells us that there's separate behavior and there's something separate that we need to do to actually protect against it. And it's not as if these are malicious, hey, if I just don't hire malicious developers, I won't have these problems. How do these security flaws get introduced? This is how we run, right? How the world pushes fast. APIs from trusted sources, right? So they must be secure, right? So that's kind of, in a sense, the API level supply chain problem, right? Or if you ever heard, hey, I need to modify this API and get it shipped because I've got time pressure or shipping pressure, right? I'll get the documentation done later, or we'll do the checks later. Also similar, but it's from a different angle, making a quick change to an API because somebody needs access to it, right? Hey, I've got some data that someone in my, the department next door needs. That's valuable to them, but I'm not going to give them direct access. I'll put together a quick API. It's internal, right? So I can get away without authentication, authorization, checking, without designing it. And that's dangerous. And that actually leads to this next point, which is we should always look at internal APIs and assume that they're going to be external at some point. And this kind of becomes a API level zero trust, right? Which is, don't trust that your internal APIs will stay internal APIs. All it takes is the data that you're providing to become important enough that a partner needs access to it now. Bam, you're on that path, right? And so if you don't go back and redesign it or rethink it and resecure it, now you've got internal APIs once upon a time that are now facing external. And so this happens. API gateways, they're handling the authentication authorization, right? Yes, in many cases. However, and developers may be told that, right? Don't worry about authenticating, authorizing it. That's going to happen at the API gateway level. Great, as long as their APIs are actually running through that gateway, right? If they didn't properly do that, or it's a rogue API, then we're not protected. As well as API gateways are looking at a different level. They're not really created, they're important and they're valuable, but they're not created to understand the business logic, to understand how the APIs connect over time and how those over time transactions can cause vulnerabilities. And then the ever present, I'll document it later, right? Our documentation is a secondary item, unfortunately, because innovation is the first. But that is unfortunately something that does happen because developers should be focused on innovating. So we need better solutions there. But that is oftentimes how these items, how these kinds of problems get introduced, even in the best of organizations that are meticulous about how they produce APIs. So for effective API security, there's several things that we think we should be thinking about, we should be looking at, and I'll go into each of these and show a little bit of how we do it at Traceable. The first is knowing your security posture, and that's not only the first because it's on the list as the first, but it is absolutely the first thing that any organization should do. You can't start protecting what you don't know you have out there, right? And so knowing your security posture means being able to discover what APIs are out there, whether or not they've been entered into a management system or whether or not it's been documented properly. We want to find the shadow APIs, the rogue APIs, the zombies that have died but are still around. And this is part of understanding our risk exposure, our overall security posture. But it's not just knowing what APIs are out there, but actually understanding them more deeply. How are they made up? What data goes through them? Which APIs connect to which other APIs? And so knowing your data exposure, or your security exposure, again, we'll come back to that in a minute. Oops, sorry. Protecting your APIs, of course, we need to be able to actively protect our APIs that we know about, and not just for known vulnerabilities, but unknown vulnerabilities. Because one thing to say, hey, okay, I'm watching for Ebola, but like we saw with Log4j, like we know from the security field, there's always new, our attackers are creative and fast. And so there's always something new to be watching out for. So we want to watch for those anomalies. Not that all anomalies, as we've heard, are problems, not by far, but a combination of finding those anomalies and then running them through behavioral analysis to understand if those are dangerous anomalies is something that we should be doing. Gaining security insights. So this we think is a very important piece as well, which is understanding the context around the APIs and the API attacks and the API usage, being able to see the traces from the time that a transaction starts to the time that it finishes, no matter where in the cloud it is. So the data needs to be captured, it needs to be filterable and searchable so that we can stop emerging attacks, so that we can do forensics on attacks that have happened, or reconnaissance oftentimes, and so that we can do threat hunting and troubleshooting, quite frankly. So having the data around an event and around an attack is important to get insights about the APIs and their usage and what's happening in our system. And then developing secure APIs, you could argue this should certainly be first, but we have to develop secure APIs in the first place, which means testing early, which means finding and fixing vulnerabilities as early in the pipe as we can. But it also makes sense at the end because there's a piece of this which is that famous, Devops Loop. The data that we learn in security or about security in production needs to come back in to the development cycle in a way that it can be acted on rapidly. And so that is a piece of this as well. So all of those are effective only if we have not just broad data, meaning we see across the communications of the services, but also deep data, meaning we also see internally the not just the north-south, but east-west, as well as deeper into the actual components and their API communications, the endpoints as well. So I'll get into that and show that in a minute. What we're talking about deep data, we're talking about headers and bodies, payloads, transaction information, piece by piece. And again, I'll show that in a minute. But why do we need that? And why is it not enough? So before I get into this, I think one of the more timely examples as an analogy could be the James Webb Telescope, right? We suddenly can see so much more now. And from that, we're going to get a better understanding of our universe. But my analogy also holds because I think it means it's personalizable for a lot of people. Who do you think is going to have a better success at finding the deep down complex problem? The colonial doctor who can do an external examination, check the temperature, hit the knee, ask them how they feel, or our modern day doctor that's got an MRI, CAT scan, ultrasound, and can actually look and see the pieces of the person moving, the gears meshing, where the cog is off, right? Where there's a misalignment. The application version of this is what we're talking about here. We call it full application context. The notion that it's not just enough to know that somebody's talking to your API, but you need to know the identity and the clients they're coming from, the roles and permissions. We need to know not just that there's API activity, but which are edge calls, which are internal calls, and what's the sequence between them. The data flow, what data is moving across those API calls, from what service to which service, what's moving in between the internal services, and when does it exit? And is that data sensitive data, right? Is it being properly authenticated and authorized? Is it encrypted? And then execution. When we talk at the code execution level, what's happening with the parameters? What is the typical values that we see in different parameters? The usage patterns normal? What are the request response data, both the headers and the body and the payloads, so that we can really see inside of what's going on with all of the transactions across the application. And then errors and latency as well. What are the typical errors and latency? Because those are still golden signals that can key us off to indications of compromise or problems. So we take this observability data, and because it's a huge amount of data and it makes sense to have AI, machine learning, look at it and to sort for baseline and figure out when there's anomalies and problems or items that need to be looked at more deeply. And what the machine learning does, uses different algorithms to then create what we call, again, full application context. That's API behavior. What are the normal baseline behavior of each API endpoint? How does it get used normally? Like, for example, if we see that there's a call pattern that always happens before an API gets triggered with a certain type of data, and suddenly it's getting triggered out of the blue with other data that wasn't in that previous call pattern, that tells us something. That tells us there's an anomaly, there's a problem potential, right? Similar with code behavior, user behavior, and data behavior. What is the normal usage of these different components that we see? And then API risk posture, which I'll show in a minute, and then user trust or threat actor, threat indexes. And with those items together, we're able to do those 4 things: help you know your security posture, protect your APIs, gain security insights, and develop secure APIs. So we'll dig into each of those. Know your security posture first. And what does that mean? So visibility of all your APIs, right? This means not just the ones that have been, as I mentioned earlier, documented or put under management, but especially even the ones that aren't, the shadow APIs, the rogue APIs, or the zombies that we turned off and kept running, right? Version 1 is still out there somewhere and it's still connected, and we didn't realize that because we stopped using it, right, as an example. So finding all of those APIs constantly, not just once, not just, hey, okay, we're here, let's understand what the map looks like, good, let's operate off of that. It's constantly changing, right? New applications, rapid development. So we need to be always scanning and finding what's being created, what's being put out there. And then API dependencies, right? Part of this is what is calling what, as I mentioned. What does the end-to-end flow look like between one service and another and one API call to the next? How does the data flow through that? And is it sensitive data? Is it being exposed? Is it getting pushed to the outside? All of the visibility we're talking about, knowing your posture, means seeing all of this data, having all this data updated constantly, continuously. And then a big one here, API endpoint risk scores. So the endpoints are what make up the API. We want to know what the risk is on each of those, because any one of those endpoints could be an attack point. And when I say risk score, where does that come from? I think some may say secret sauce. We say, hey, this is something that you should see and be able to adjust and understand, right? That looks at 2 different things in general at a high level, which is what's the likelihood of a breach and what's the impact of a breach if this particular endpoint gets breached. And that's made up of lots of data points that you can adjust and fiddle with and add to that defines things like, okay, is it encrypted? Is it external facing? Are we passing data through this API to a system that we're not authorizing, right? Does this API endpoint, for example, get called often from multiple IPs around the world? That could indicate more, that's more risky. So there's many different characteristics that we'll look at to calculate and to show a risk score. And those risk scores are important because that's how you prioritize, right? If you have thousands of APIs and you need to keep them secure, you can't do that to thousands of APIs all at once. You have to start with the worst ones, the most dangerous ones. And then which data, as I mentioned, is exposed, which sensitive data and where is it flowing, and conformance analysis. We have documentation. Our developers did their documentation great. Oftentimes, more than not, it gets out of date quickly or doesn't get done. Because again, as I mentioned, we're about innovating, not about documenting. And so one is auto creation of the documentation based on traffic that's seen. So this now is documentation that's live and updated constantly, but also the ability to then compare that against anything we do have documented to identify where there's a problem, where there's inadequate documentation, or where we have something where we didn't know about, for example. So I'm gonna try switching here to, oh, I lost my tabs, okay. So what I'll show you is knowing your security posture. And let's see if I can, okay, cool. So this is the product, Traceable AI. And what we're looking at right now is the API catalog. which gives us a lot of abilities, and I'm not going to cover all of them, but I will touch on a few that we talked about. Right now, we're looking at the first place we end up in API activity. These are the APIs that are actively getting called right now. This is the catalog of all of the API endpoints in our application. You'll note that it can be ordered by the risk. We're seeing the sensitive data information, but this is a kind of low-level view. And really what we might start with is a 30,000-foot view. How do all of the pieces of our application connect? We have our Nginx, our external system. We can see how it connects to the internal systems, internal services, so we can see east-west traffic as well. And any one of these, if we want to get more data, we'll click into it, and we can see, again, follow the path and understand how the pieces are connected. I might want to say, okay, well, this particular service that's come up, I want to get more about that because I'm not familiar with who this person is. But I'm going to go ahead as an example and dig into the Nginx Trace Shop service. This is Trace Shop is a demo app that we use. And I do have lots of observability data, but where I want us to focus is the endpoints, right? So we saw before we had all of the endpoints in the system. These are the endpoints of this particular service. So these are all of the ways that somebody could invoke this service, talk to this service, attack this service. And we can see that it's ordered here, highest risk first. I can get a summary, as I mentioned, likelihood and impact. This would imply to me that these top ones, especially these top two, are ones that I probably want to take a look at. And I can dig into why, looking at its overall information. I can see the risk information here, and this is showing a sampling of here's where we found items that scored against your criteria, and the kind of things that you should be looking at to know where this risk score is coming from. But to understand the security posture is not just about the risk score, but several other things like vulnerabilities, the sensitive data that we're exposing. Here is what we're seeing here is email is this piece of sensitive data being exposed by this particular API endpoint. And we're seeing it now in the OpenAPI spec that was generated and is constantly updated. So I can find where I'm actually using that sensitive data. This is now a sensitive data view from the perspective of one service or one API set. I can also look at this from the other perspective, which is if I'm coming in and responsible for making sure we stay clean, what's the set of sensitive data that's being exposed by my app as a whole? And we can see here listed the different sensitive data types and what the exposure looks like. So if I dig into, for example, credit card CVC, right? This is the hidden number that's only on your card, so nobody knows it, right? I can see that there's actually 4 services across and 4 different API endpoints, one of each in each service, that are actually exposing that data. And this is actionable data, of course. Here I even see this is an external one. That's probably why it's a higher risk score. So that comes in here as well to help me identify what I want to take a look at. And I can dig down into that and again, identify where that is in the spec. Further, I can go deeper in and actually, if I'm tracing that down and I want to learn more about that, I can look at what we call the API DNA. Now this, again, this is all found by our sensors that are on the network, watching your application just do its thing. And we build all of this out of that, and we keep this updated out of that. And I'm seeing now all of the parameters, all of the that are used by this API endpoint, and they're tagged if they're, for example, sensitive. And I can actually have it say dish sensitive. And so here I see the actual parameter name, which is of the type that we identified earlier, the credit card CVC. And so here is the parameter information. Here's what we've collected and learned about the parameter and continue to update. And so I've got basically the visibility from the very top 30,000-foot level view of my services and my application, and can drill down all the way operationally into the depths of even the parameters and what those parameters are like to understand where where I have vulnerabilities that I need to adjust, or that I need to work with.
Is this a stock dashboard we're looking at or something custom?
This is a stock dashboard right now, yeah. Then regarding sensitive data, we already covered that. So let's see, we're going to switch back now. Let's see if I can pull this. There we go. Okay, that's not as smooth a switch as I was hoping it would be. Okay, so that's your posture. The next piece is protecting your APIs. So we know now we have visibility of all of the APIs that are in our system, and we have a sense of where the risk level is on them. How do we go about protecting them? How do we stop them from known attacks? Now, that can happen in many ways, but there's particular things we want to make sure we're paying attention to. One, we need to make sure we're not just protecting from external attacks, because we see at our customers a lot of internal attacks as well, like employees that might be using an internal platform to scrape data that they're going to sell to the black market, right? For example. But we also need to be able to protect from the OWASP API top 10, but also the OWASP Web top 10 is ideal as well. Why would you say that? Because don't I have WAFs, right? So why do I need to have a system that worries about the web top 10 and the API top 10? The reason is because there's a value in holistically seeing everything that's going on. If I have one system that sees a set of attacks from one list, and another system that sees a set of attacks that are kind of part of a different set of attacks, our attackers are not operating by lists or by how old an attack is. They're going to use everything at their disposal. So ideally, what I want to be able to see is all of those pieces together, so that I can understand the transactions and how they're maneuvering across those pieces to get into my system. Now, this also means we should have the ability to surgically prevent exploits like we saw with Log4Shell, where we're at the API level, we can actually block the API, the offending or potentially offending API call, right? If you do a Log4j shell call for LDAP, don't let that happen, right? Block it right there, because we're in at that level as well. Meaning that gives you, that's a triage, right? That shouldn't be the ultimate solution, but that gives you the umbrella, the shield by which to go and fix the real problem, which is upgrading all of the Log4js, which takes time. So this is very important. We want to be able to track the activity of our APIs at the user or what we call threat actor level. This is unique, I think, to Traceable. It's very important. It's not enough to look at IPs. We know that because it's easy to switch IPs constantly. Resetting a token or changing your JOT information. What we're looking for is the ability to basically create a storyline of a user. Most users that are attacking with APIs are authenticating in some way. This is where BOLA is the #1 attack, because you're authenticating, but you're taking advantage of poor authorization, right? So with the user information, we can look at the history of a user and we can block from that perspective. And I'll show you that in a minute. We need to be able to protect the API business logic, not just individual transactions, but over time, the kinds of attacks that happen low and slow, because the business logic is actually defined by the APIs. This is different from web applications where you're basically fronting to logic that's happening in the back end. The APIs really define the business logic, and they have direct access to the data. So we need to be able to understand when that's happening, and that means understanding the context of the application and the APIs and how they get called together. And then, of course, stopping data exfiltration in general. And we saw a little bit of that. Fraudulent activities, right, and bad bots. These are things that happen against APIs more and more nowadays. So let's switch to that. No. So if we look at the area under API protection, we actually get dropped onto the threat actor screen. Now this is something once once it's available to your system, you may actually start getting alerted based on threat actors instead of like commonly in the SOC, you're getting like, hey, there's events going on and you want a filtered version of those. This is how we filter down the activity, right? There may be 600 BOLAs and 30 SQLIs, but they were all perpetrated by the same user trying to get into your system, right? That's the stopping point that we want to have, or at least one of them. And we also have APIs under threat, so constantly showing you what's being attacked and worked on. But I want to jump us to events and focus in on a particular one. We can filter. This is kind of the dump of all of them. We can focus on high events and let's take a look at this authorization bypass, this BOLA event. Now, we have lots of data about it, including what the AI, why it believes that this is a BOLA event. And what we're doing is giving the information because, especially with BOLA, we want a security analyst is going to look at this and say, okay, help me to be efficient in figuring out if I've got an event here. Now, lots of data available here, including, like I mentioned earlier, the requests information, the response information, the attributes of the communication. Over here on the right, what we're seeing is the user API flow. So this is effectively the API kill chain. Every API that got called by this attacker on the way to the attack point, right? And we use that to understand the attack more and to understand when it's happening, when we see it again, or this could be to the reconnaissance. But as I mentioned, with the user, we have a unique vantage point, which we'll focus in on. We can see that this was an authenticated user, the very stealthy hacker at dark web. But right here now, I've jumped in and I can see not just the BOLA, but I can see that they've done a lot of different attacks, cross-site scripting, SQL injection, there's that authorization bypass. So over time, they've been attacking my system. They've been trying to get into this application. They've been trying very many different attacks. I can also see that the system, our system has Traceable has basically, because of all of this behavior, it's ratcheted up consistently each time there is an attack, what we call the threat index for this threat actor. So they're at 100, so they're marked as critical. Now we can actually set a rule that says auto block a threat actor once they hit some threshold, or again, we can make the data available for organizations that are not as comfortable to do auto blocking. But what this is very surgical, right? This user for this application will get blocked. Nobody else is going to get blocked. And what we see here is, okay, with the set of data of the history of their attacks, their threat index, and oh, by the way, they've come from a few IP addresses. This is not normal. Maybe they're traveling, but right, 30 IP addresses is a bit out of, actually, it's more than that at this point. Enough, I'm seeing enough here as an analyst to say, you know what, this looks to me like someone that needs to be blocked. It's as simple as doing a deny and confirming. Oh, I probably shouldn't do that. Shared demo system, sorry. So that would basically put them on the deny list, and then for this application, any future attacks or any future attempts to communicate through it would be blocked. The other part of protection is, switch over to this one, is data protection. So data exfiltration, I mentioned, is really one of the big concerns that we have. It's not just stealing, you know, our reputation or funds, but getting the data out. That's a big concern. And so we have the ability to show here, for example, at the user level, are the users that are attacking, that are exfiltrating data, and get more information about that and where they're doing that from. We can, for example, look at specific data types. I want to know, for example, social security numbers. And I can see that several folks, I don't know why we're looking at 3 lakes, sorry. So I can see that for social security numbers, and we're filtering live, I've got Chris Williams on the top here, and I can see that he's pulled out quite a bit of data, sensitive data, and there's that social security one. I can go deeper. I can dig and find out more by hitting the filter. We'll look at this again in a second, but this is basically taking us to our trace data lake where we have all that data that I've been talking about. And all of these transactions are transactions where this user has basically gotten access to this sensitive data type. So any one of these I should be able to open up. And again, I can see the details of the transaction, including the response, including that social security number. Now this is obfuscated by our system. This is showing us the metadata, but we know that this is a social security number that was stolen or exfiltrated, and we have the name and information because we didn't obfuscate that, so that we can work with that data to resolve the situation. But the other piece of this, of course, is how do you stop that? I can look at this from a services perspective, and I can see I've got actually two services that are, and specifically two endpoints in two services that I've got most of my data getting exfiltrated from. So that tells me this is an area that I need to stick my devs on and get tightened up because I'm losing a lot of data through this. Again, we see a similar view, sensitive data, and the open API spec, and the overall security posture of this API endpoint that is getting data exfiltrated through it. So we'll switch back. Sorry, I didn't think the switching cost would be so high on this. Okay. So that's protecting your APIs. There's this other piece, which is gaining security insights. I just showed you a little piece of that, which is diving into the data lake and being able to look around and find the details. But really, this is about storing all the transactions of all the data, not just the known bad data, because then you don't see the whole story. Now, of course, there's data reduction going on, some clever stuff here, because that's a lot of data. And that's why we do a lot of, in the back end in the SaaS cloud. But we want to be able to analyze all that traffic, request, response, header, bodies, payloads, look at the performance metrics, the calls, the error patterns, so that we can look for the details of, like, if we're doing forensics of an attack that happened, or find reconnaissance that's going on, or doing the threat hunting, and also fraud detection. So we've got customers where we've worked with where this was the tip of them being able to find, for example, I think I mentioned earlier, the internal employee that was siphoning off data and then selling it on the black market. Also being able to find things like gift card fraud, where an API was getting used repeatedly to create new users and then register the new users so that they could keep getting sent gift cards for getting new users registered, right? And so having access to this data opens up the ability to see more than just the attack that's happening. And that is what we'll show next. So for that, we'll actually start. So for that, we'll actually start at the BOLA event that we were looking at earlier. There, that guy. And we saw that I have lots of data around the attack, around the information, the metadata, the body and information. And I've got that API attack sequence, basically, right? So this is a point where I might say, okay, well, this is the attack point. I want to go in deeper and understand what actually happened. What was the set of data within that transaction? This is going to now take me into the bit-by-bit communications across all of the components and the timing. So this is basically distributed tracing. And I can look into each one of those and go even deeper to find the actual details of response and the attributes there. But this is forensics, this is detail at an attack level, right? This is an attack. And oftentimes what happens is multiple attacks in a session. Now our system tracks the user session. It's not just when they log in and out and change their session cookie, but a session is typically going to have more attacks. So maybe what I really want to see is, okay, if this attack was the drop in the pond, what else happened? What's the collateral damage, right? What other attacks happened? What did this lead to? So here I'm now looking at the session information. Let's say, so I can filter on basically anything that we store data on, but let's say I want to simply look at whether or not they got access to personal information. So I can query that. I see that there were 2 transactions that happened. I can look at those transactions and I can see, okay, the request makes sense that there's information there, but I can also see in the response where a phone number basically was gotten access to, right? So again, having access to the details where you can actually start slicing through and saying, okay, this is the attack point, what's happening outside, around that is very valuable to being able to find problems and get ahead of them. So developing secure APIs, I'll just work it this way. It comes from multiple places. It's not just shift left. But there's also, we have data on risk profiles of APIs. Right? Imagine if a developer in a pipeline could be blocked because the developer introduced use of an API that we know to be risky now, right? Because after seeing it in production, we're starting to see that there's a problem, right? Or just having the risk profiles so we can make sure development is focusing on the highest risk API endpoints or APIs. Finding the vulnerabilities, those OWASP API vulnerabilities, the other vulnerabilities that are in those APIs and those endpoints, and then providing remediation suggestions, and I'll show that. And then tracking the lifecycle of those vulnerabilities. And this is coming to be able to compare those APIs against best practices of the industry and of the company policies to say, for example, well, if I have sensitive data that's being sent to an external system and it's not being authorized, then I should block that, right? So, and then of course tests of these in the CI/CD pipeline. These are all things that we should be able to get from a solution to be able to get better at our development of secure APIs. So last thing here, and we're almost wrapped. And what I'll show you is under the catalog, we have, for example, vulnerabilities. We have this information per each API endpoint. So here I see in this API endpoint, I've got lack of encryption as a vulnerability and query parameter contains sensitive data. I can look at it from that perspective again, each service, each API endpoint, but I can also look at it holistically across my entire application. What are my vulnerabilities? It looks like I've got 3 main services with vulnerabilities. My front end's got lack of encryption and some other things. If I look deeper, I can see what those actually are and which ones, what's the state of those, plus getting some information about mitigation of those. So we can help also create the JIRA so that we can quickly roll those into whatever system development is using to track and fix these problems. So with that, key takeaways. API security, as we know, is a rapidly growing battlefront. Securing these APIs requires new methods and controls, even finding them. And to be effective at API security, we need to know what our security posture is, know what we have out there. We need to be able to actively protect them. We need to be able to look at the data around the attacks to understand what else is happening and what's the collateral damage. And we need to make sure that we're making secure APIs in the first place. And all of this requires full application context, the deep, not just the broad. So with that, I'm done. Any questions? I know it's the end of the day. All right, thank you very much for your time.